Hey, welcome in. My name is George, and thank you for joining us on the channel today. And as we get going here, as we get moving and grooving, we're gonna do next 30 days. We're gonna have a little series. All right, well, we have the Parafair podcast. Let me bring that back. We have a Parafair podcast, and as much as I like the Parafair podcast, there's so many other things I like to do and introduce you to as we are the closest. We are doing so many different things and I have so many different interests. I love podcasting. I love just doing a lot of amazing things here on the internet. I think the internet's a wonderful place where you can do a lot of great things. But in meanwhile, I have a lot of interest. I'm going to show you a lot of the hobbies I like to do. One of the things that I like to do is I like computers. I like computers a lot. I like not just computers. I like electronics a lot. So let me give a little backstory. I have a limited, but kind of experience with boards or whatever. Went to school, got an associate degree in electronics a long time ago, and I kind of went another way in my life with that degree. And so now I'm going and just dabbling in it, looking at how technology has changed. When I was doing it, it was a little bit different, but you're still using the same tools. You're using your multimeters, you still got resistors, you got capacitors, but I'm just next couple days or weeks, we're just getting back into, how people are repairing these boards. As I look at how people are repairing boards and just getting back into it, there's a lot of guys out there who are repairing boards and there's some amazing things. And I like the equipment they have and the things that they're using. Um, and it's kind of cool just to see them. There's a little strategy I've learned in life is what do you notice? What do you wonder? And they utilize this a lot. And so it's kind of cool to see them just get a board that per people, they buy them on eBay, they buy them all Amazon. I don't know. They buy them parts stores. I don't know. People just give them to them. And people say, hey, the boards aren't working. So it's kind of nice to people, watch these guys put boards together. There's two guys that I've been watching on YouTube and they just they just take care of them and they dabble in it. So we'll be watching a lot of videos, reaction videos to these guys put these boards together. So sit back, we'll pause it. We'll go from there. So sit back, enjoy it. And here we have our first guy. And this guy, quite the character. He's quite the character as he puts this board together and he just makes it happen, for the most part. He does a really good job of with his microscope. And so let's see what he does with his situation. And we should be very entertained in what he does. So sit back, watch, and here we go. Here we go.
Hello and welcome to another video. Today we have a Gigabyte B550 Gaming X V2 on our bench. It says it's for parts only and it is missing its socket cover. And I think I see some physical damage also around the...
And one of the things I'm trying to do is just one of the ways you get into anything that you're doing is just understanding the vocabulary, the words that they're using, the socket covers, capacitors, and whatnot. So, like I said, we're learning as we go, and you should be interested to watch and break this board down for
the socket where there's missing resistors. But I want to have a look at this. This is also damage to every pin of the PCIe slots. So all of these locking mechanisms are missing. And also 3 of the locking mechanisms on the DDR slots are missing. But that shouldn't worry us, because I want to see if we can get this board working. So before actually doing anything to it, I would want to take some measurements to see if there's even any reason to start with this, or if there's like a big short on 3.3 volts or something like that.
One of the things that they always do, these two guys that I watch a lot, is they are checking these boards. They're checking these boards and they're making sure that when you get these boards, one thing I've learned is you don't just stick your power supply in there and start them up, because they could have some shorts in there. They're going to take some measurements on some of the pins so that they know that for the most part, the wiring and whatnot is intact. They don't have any shorts in there, and they're just being rather safe and what they're doing. So that's very important as you are working with these boards. Be careful because it could cause you a lot of problems down the road. So it's always good to just double check. And what I like about what he's going to do, he's going to he has his meters up here, and he's going to be looking for certain voltage that's going to come across and whatnot. So in amps.
So let's get a good ground point. So we got a ground, and let's start at the 24 pin. So we start in the bottom left, 3.3 volts. Kilo ohms and rising, that's good. 5 VSB, fourth pin from the top left. Kilo ohms and rising. Then 12 volts, second pin from the top left. Kilo ohms and rising, second pin from the top right is 5 volts. Kilo ohms and rising. That looks very, very good. Let's move on to the 24 pin of the CPU, auxiliary power.
And as you are doing these PCs and you're building, one thing we are building PCs here. And one thing that you're gonna have to do, that first little 24 volt one he checked out, that's where you're gonna put you'll see when you put it together, your 24 pin connector to your power supply will go there. So that's something that just has to work, or you're gonna have a lot of problems.
The 8 pin, and I seem to get a high reading because I'll get OL, so open line, and then we try to get the upper one close to the notch, and we want to probe the inductors, and there's also no short. So 12 volts also not shorted into the CPU. So there's nothing obviously shorted here. And the big problem, as you can see, is that the socket cover was missing when I got this. And as far as I know, this is a Foxconn socket. And I actually got off of a donor board, I was able to pull out a socket. I did break it, if you can see right there and there, but it should still be fine for trying to use this. So let's see. We need to put the lever into there. I know that there are ways to remove these sockets without breaking them, but I just can't happen to do that. It always happens to me that I break these when I take these off. But they still do work most of the time. So the socket is now on here, the socket cover, and it should be fine. So let's then
Yeah, it's very important to put that over those pins, and when you put that CPU on, CPU on next, these pins get a little damaged, and it can make a big difference of if it's going to work or not. And you're going to spend a lot of hours of. I have a board right now I'm working on. Just like the pins, just aligned wrong and everything. So it's got to just work on it.
Add a processor into here. Let's start with the 3000G and see for the passive power consumption if you can see anything. So to check if the connection to the socket is proper, you can use a DDR socket tester or a DDR data line tester. So let's connect this to one of these sockets. And now if we turn this on, we want almost all of the LEDs to light up. And as we can see, they are basically all on that need to be on. Sometimes you have ones like that one that sometimes go off and on. That is just bad contact in the socket. But all of them are there that need to be there. So that means that the socket cover is sitting properly and the CPU is also sitting properly.
Yeah, that little tool he has right there, I don't have that in my arsenal just yet. And I'm looking at getting one. And so that just kind of tells me, that CPU, everything is lined up, everything's ready to go. So like you said, one of them may go on and off. And so that that something's not making a good connection. So I'm looking at trying to purchase one of those, and it should make my life a little bit easier as I look at these boards. But like I said, we're learning new little things. What are the guys who are doing this on a day-to-day basis? What are they using to enhance their game? And so this is one of the things that we're looking at. So here we go.
In the socket. So I got a stick of RAM into here. We have a processor in here. Let me get a speaker attached and also a power button. Because this is a gigabyte board, we should be able to get postcodes out of the PCIe slots also. Does this have debug LEDs? Most often Gigabyte has them in the bottom right, but I don't see any. Yeah, so let's see for getting the PCIe postcard in here. So now for the moment of truth, let's see for its passive power consumption. 200 milliamps, that's a little bit higher than I would want it, but it looks fine. Let's hit the power button. Reaction to the power button, 3 amps. Changing power consumption. And it complains about something. Is this just working?
What he means by complaining about something, there is a little, on these boards, there's a little buzzer. And so you can buy these little buzzers, and so that if it's sending out an error code, it'll beep and it'll go, beep 1 time, 2 times, 3 times, 4 times, whatever it tells you. It kind of tells you what's going on with the board and what's not working right with the board. So that's what he's looking for. As you can put down here, his little switch and then his little buzzer to help him find and listen for the correct diagnosis of what's going on with the board.
Really? It's complaining about something, but I'm not too sure what. It's probably the VGA that I have not connected. Let's see here. Okay, there was a post beep. And now it's constantly. Let's see here. Sometimes it beeps because it wants a proper CPU fan that has a PWM signal. So let's connect the proper one also here. And let's turn this off once more because it's beeping so loudly at me. Turning it on. Reset going on and off. That's good a sign. 0.2 amps. And there's a post screen. It just posts. But
I tell you, it's when you're working on these boards, and I'm having one right now that's just giving me the blues. And that post screen, it's kind of when you get that post screen and you're just so excited to get one. And you're like, wow, I got a post screen. I think we can make some progress here. So as we look at it and we get excited as technicians, whatever, we get that post screen, and it just makes a world of difference in your attitude. He's like, I'm making some progress here. So he's excited that he got that.
For whatever reason, the speaker is very angry at me. So let's take that out and get some USB connected into here and see. USB seems to be working fine, okay. But we are in BIOS. So this seems to be working insane. So all this needed is a socket cover, and I basically did most of the work before already. Well then.
Yeah, he's thinking that cover for that CPU, I guess maybe the person that was running that board, they didn't have the cover on it. They didn't have the cover on the CPU, so that could have been affecting them, how the board was not running right. And so that kind of gives me an idea of the board that I have. That reason maybe that I might have to get a cover for it to make it run a little bit better. So that's what I like about these videos. You can learn so much each time you open one of these guys. These guys are like surgeons with these boards. I love it.
I guess I will need to put some more RAM into here, get into Windows and test that. But it has a very interesting issue. The PS on isn't going low. As you can see, the board is turned off. We have 500 milliamps of power consumption and the cooler is still spinning. That means the PS on is still on, and you can see the LED lights still on my tester. That means the PS on isn't being pulled low properly. So there's probably some missing component somewhere that we will have to find, because the PS on is not reacting properly as it should. Because it does react to the power button now, but it's currently at S0 state where PS on is being pulled low, but it should be at S5 state, which is the standby where the 12 volts, 5 volts and 3.3 volts are not present. So there is something wrong with this board still, and we will
One thing I can say as he breaks these things down is you're going to have to know your numbers your amperage, your voltages are coming out of these everything that you're testing. I'm in the midst of fixing a dryer at this time. Fixing a dryer. I had a talk with someone today about fixing a dryer and just getting how do you say it? Just getting back to learning your voltages, learning your multimeter. That that multimeter that you're going to have. You can have a digital one, an analog one. That kind of can tell you if your board, or not just your board, but just if you have a short, is able to get voltage to there. So make sure that you are practice with your multimeter, and you should be good. And let's continue.
Have to figure out what, and for that we will probably need the microscope now. I would expect either damage around the CPU socket, or it is near the SIO, because that is responsible for assorting the different sleep states. So let's see for that. So this is the physical damage that I saw, and I don't think that there was any component.
One thing I get really, these guys, I like his setup he has here. And as you look at, he has a microscope to look at these boards. When I started getting back into this, I'm like, man, how these people look, I realized, like I said, I haven't done this in a long time. And it's just looking at how some of the technology has changed. When we were looking at boards a long time ago, we did it with our, little magnifying glass. But these guys now, they have these microscopes, and it is, just can see what all kind of stuff's going on here. So let's continue.
Ever here, because you can see that they are not flat, the pads, but they mostly have like a conical shape to it. So that means that there probably was never a component fitted. If they are like round like this, there was probably nothing ever there. So let's see. On top of the socket, this also looks fine. Let's see to the mounting holes closer, but nothing damaged here as well. So here the left side of the CPU socket, and all of this looks also to be fine.
And what he's doing, he's just doing a basic. What does he notice? What is he wondering? What's going on? And this skill, it's kind of one of those skills that the technician, he's on a visual inspection of the board and making sure that everything, looking for anything that could be, just doesn't look right. Anything that doesn't look right, looks abnormal. He is making sure to get it out of there. They say, hey, this could be the problem why I'm not getting certain amperage.
The BIOS also looks completely untouched, and this looks like it is something like the SIO, but I don't think that.
And then when you hear people say it looks like it hasn't been touched, he'll say that a lot. Is sometimes you'll get boards, and people have worked on these boards. They have done certain things to these boards, and so he's trying to say, no one has really touched this board. I'm the first guy who kind of like touched it, and so he's looking for a different thing. Maybe it's been brought in before, and so you're looking at maybe somebody did some shoddy work on it. So who knows?
At this position, this is the actual SIO. This is probably used for like Q flash or something like that here, but no problems so far. Everything looks fine. Checking around the BIOS battery, also no problems. Let's check around the circuitry of the 24-pin adapter, because there sometimes is a MOSFET here that is related to the 24-pin that can be damaged. But it looks very fine here. Also no problems here. Let's look above the DDR sockets where we have the actual damage, because there's sometimes some logic hidden here, but in this case it is not. There's very few things here. Okay, so there's this huge heatsink close to here that I will probably have to take off in order to see under there if there's anything damaged, because so far close to the front pedal header there's no damage here. So let me take off this big cover here, this big heatsink, and let's see under there if we can see any damage. And while we have the board turned around, let's have a good look at the back side. This is the PCH area, and all of this looks fine. there's very few components on the backside of this board. So backside of the CPU socket. Also everything looks fine. This looks like for PCIe or similar things. And no damage to these caps. Also these caps in good condition. I was able to find this scratch right here.
Yeah.
And the big question is,
he found this scratch right here. And like I said, with these guys with these microscopes, and just when you get a board or you bring something in, you're looking for any abnormalities that you may find or what you see. And right there, you see this scratch that's going across here, these little trace lines right here. So this could have a big effect on why the board is getting certain power to certain areas and why it's not responding. So let's see what he does with it.
Did this go through or not? Are these lines cut right here or not? Let's get an X-Acto knife. And let's see right here if these are actually broken or not. These might actually be damaged. This might actually be our problem here. Let me get a grinder. And let's also go a little bit closer to the area that we can see this better.
This grinder that he uses on these boards, it's kind of cool how he's going to use it. And just the tool, like you said, they had that X-Acto knife. He pushes it apart a little bit. With this grinder, it's kind of cool.
Tom? Oh yeah, now we can definitely see that these are broken. Oh yeah. So that is most likely our problem here. That if we grind this back, we can definitely see that this is broken. Let's clean it up a little bit more. That will also reveal more here. So the first one that I grinded is probably most likely fine, but the ones after that are definitely broken. Like the ones all here are all broken through. This one is probably also broken. There's like a hairline crack. And I also want to see for the one right here. So on that one, we also definitely want to put a blob of solder to bridge those, just to be sure. And the one next to it, the one on the left here, this one didn't get damaged. But yeah, we definitely want to bridge this as well. And yeah, we will have to...
Yeah, what he's going to do is take a little, take some flux and put some flux on there, and then put a little solder to bridge it back together so that they can make a really good contact. So it'll be nice how he puts it together. He's done, like I said, he's
prepared these tracks here, and this should be fine. This one shouldn't be broken through. There should be continuity through all of this. Like if you get a spot, yeah, you can see there's good copper there. So no problem here. But yeah, all of these lines are broken through, and we can't really tell what they are for, but they definitely need to be repaired in order to probably get the PS-on logic back to how it's supposed to work. So let's grind these open. So now you can definitely see the breaks where they are just cut through in the middle there. Some a little bit less, like these two in the middle definitely got less hit than that one on the left. But yeah, they're definitely broken. And what we will have to do, we will have to tin these up now. And when they tinned up, we will have to run some jumper wire. So let's see. I need to get this board a little bit more stabilized. That I can work better on here, because currently it's wobbling around a lot.
Like he's cleaning it up a little bit. He's gonna get a little jumper wire, and so he's gonna put some flux on there, put the jumper wire in there, and then some solder on top of it, and it should clean it up for him really nice.
So first, what I will do, we will apply some flux onto here. And with the flux that we now have, let's take a good big soldering tip in order to apply a good amount of solder to all of the parts, because that's what makes these jumper ones, these jumper jobs a lot easier. When you have a good amount of solder on each of the parts, then the wire will stick just a lot better. So let's see right here. Get them all properly tinned up. And also the one here on the side. Get a good amount of solder here. Yeah, and that one is definitely bridged now. So with that one we won't have a problem. So this part is repaired, the left one, as you can see, a big blob of solder bridged over there. And yeah, on these now, we will have to do some more work. And it seems like I forgot this trace right here. There's another one, very small trace here that I didn't notice. Yep, another trace that I didn't notice that it was there. Let me get that sorted up as well.
One thing you're going to do, you're going to have to be really, when you're repairing these boards is, like I said, you have to be really, really patient with yourself. They make it sound like, when these guys putting these boards back together and they've had lots of years of soldering these things and using their flux, using their wires and stuff. So I know the first couple of times you're going to do this, you're going to be like, well, I can't do this. You got to be patient with yourself. You're going to have that internal battle like we always do with ourselves is, hey, can I do this? It's kind of rough, but you're going to stick with it and just realize if it doesn't happen the first time, just keep trying.
Funny. Human. Right.
As you can look right there, you can see the little wires are they're coming in there pretty nicely. So just takes a lot of patience and a lot of just trial and error, moving things around. Like I said, these boards aren't that big, so you have to be really, really patient with yourself.
So there we have it. They are all repaired now. We can see this one was just bridged. This one has a wire. This one has a wire here. Then we have a wire right there. Another one going there. From there to there. One more going from there to there. And one going from here to here. And they're not perfect with the way that I threw them, of like they're having tail ends and stuff like that. But it doesn't matter, because they, as long as they're not touching and then we are isolating them with solder mask, they are fine like they are. Most important thing.
Yeah, I was kind of worried about how they have a little tail to them. Would it matter? But he said it didn't matter. So we'll see if it does matter or not. But like you said, these things right here, you see this little tail right here. But we'll, like I said, it's just a lot of good practice there.
That they make good connection and that we don't have any breaks anymore.
Yeah. Like you said, as long as it makes a good connection and we don't have any breaks, that's the main thing we're looking for. It's a good connection, doesn't have any breaks.
And I got to be honest, I'm not too sure if this will actually fix our problem here. It definitely was a problem that needs to be fixed, but it could be that this is completely unrelated and that we still maybe have a BIOS issue or something like that. But this definitely had to be done for whatever functionality that we have restored with this. So next step is to get some solder mask onto here. Let's get my good old ugly green solder mask into here and insulate these. So we got good amount of solder mask on here now, and let's cure them. And now it's also insulated, so we should have a good connection, everything here. Yeah, that looks fine. Good connection, insulated. We are fine. So these are all restored. Let's see if this is already the solution to our problem of this board not pulling PS on low after.
Yeah. Only way he's trying to build an insulation there. He doesn't want to spark anything. He doesn't want to start anything up. So he put this solution on there to cure it up a little bit. Hopefully, he says it may help, it may not, you know. But when you see certain things on the boards that don't look right, the more that you can, if you can repair them, and just don't assume that, hey, this little thing right here doesn't matter. You don't know. You don't know. The more that you can get a clean board, I call it a clean board. You get a board that's clean, that doesn't have any problems, and you can fix them. That's the more you can do. You know, that's the best thing you can do. Just don't worry about it. Just get it nice and clean.
It has been started once. So let's try that. So let's see here now. Get everything connected again. So let's see then. Passive power consumption in again. 190 milliamps, similar as to before. Let's start this up. So board boots up like normally, like before. Let's see if we get a new post screen, because this is still the stuck old post screen that we have. About 3 amps of power consumption, 4 amps, that looks good. Do we get a beep at any point? There's the beep. We get a new post screen, that is very good. Let's see that we get into the BIOS. Okay, and now let's see if we press the power button, if it goes to the actual S5 state. It actually does. There it is. 110 milliamps now. And now you can also, when I close the post screen, you can now see that the cooler isn't turning anymore. So there was actually a problem with some line that puts the PS on high again or disables the MOSFET that wasn't reaching where it's supposed to be reaching. So there wasn't any missing components here, but damaged traces, which is basically like missing a 0-ohm resistor, for example. And there were like 6 or 7 traces that we needed to repair here. And now the board turns on and off properly, which is great. And there's probably even more functionality that we've restored there.
Yeah, it sounds like I said, he's got his board. He found those trace lines that were bad on the board, and he went in there and he dealt with them. He said, I don't know, it could be the problem, might not be the problem, but I'm going to go ahead and repair them. And one thing I like about this guy is he doesn't see bad boards. He doesn't, when he gets a board, he knows he has the skills to fix these boards. A lot of this stuff, when you're repairing a lot of this stuff, you're going to have to have that confidence that, hey, whatever board I get is I can fix this board. And going in there and thinking that you can fix it, that's half the battle. That's half the battle that you're going to have to do is just believing that the skills you have. And if you don't know how to do it, have a resource out there so that you can get back to, fixing the board. And hopefully it makes a big difference. Makes a huge difference in your success rate with these boards.
I want to test this board properly now, because there might be further damage, who knows. So let me get a M.2 into here, populate all of the RAM's slots.
So what he did was he populated all the RAM spots right here, and then he put a little hard drive in there just to test a little bit more, making sure that what he repaired is great. But he said maybe might be some other problems in here, so he's gonna go in there and try to push it a little bit harder. And that's the thing about these boards: you fix one thing, and then you can say, "Hey, let me push it a little bit more, and see if we can get it to go." Doing this little test.
So I've now got 4 sticks of RAM in here. I got a 3100 into here and a GPU in order to test the first PCIe slot as well. It doesn't really matter that there's no heatsink on the PCH right now, because the FCH, because the B550 really doesn't get too hot. And I got an M.2 into there to boot into Windows. And then I would want to try the audio devices, so the Ethernet, the USB, in order to test them that they are working. And that is the most important test that I want to do. And in addition to with the 4 DIMMs of RAM. But the 4 DIMMs of RAM already posted. The 3100 gets recognized just like the GPU, which is great to see. So I will now get into Windows and we'll do some more tests here and see for the Ethernet and so on and so forth. And now our board is connected. So we do have working Ethernet, we do have working audio now, and I'm also cycling through different USB ports at the back just to see with the thumb drive, just to see that it's recognized just like that. So yeah, very interesting repair. I first thought that there might be not a repair here at all, but the not turning off properly after pressing the power button, I've seen that multiple times already, and you can circumvent it by just cycling your power supply, but who wants to do that? But now we actually got the board to a state where it works properly fine. And if you have missing socket covers like that, you can also just buy sockets online on AliExpress and then separate from them and then put them on. Like, you don't need to do it like I did it, taking it from a donor bot, but you can definitely just buy one. Be mindful, there's Foxconn and one different brand, another one, that you have to be mindful of what kind of socket you're getting. But yeah, the board is working. There are the clips for the PCIe latches missing. I will have a look if I have them anywhere, and if I can put them onto there. The DDR latches I cannot repair because I'm pretty surely for those you will need to replace the socket, and I'm not looking forward to doing that on 3 of the DDR sockets. But definitely will do those for the PCIe latches in order to have them properly there. So with that, this was Mainboard Medic. All of my tools, as always, are linked in the video description. If you want to get one of these amp meters that I'm using, that I'm building myself, email me. You can purchase one of them. I have a post about them on my YouTube community.
Yeah, this guy, he is pretty slick. He's pretty slick in how he has these great little meters and everything. He knows his voltage. He knows what he's looking for. And one thing I can say about him is every time I watch the video, he does the same thing, the same step by step process of troubleshooting boards. And that's what you're going to have to do is when you're doing your workflow. And one thing I'm going to have to do is, this is what I'm looking for, step 1, step 2, step 3, and just do it over and over again. A lot of times we go in there where we have a problem and we skip a step. We said, well, there's no shorts in the board. You know, like he did, the first thing he did was he wanted to see if there's any shorts in the board. And then as he put the socket cover on the CPU, making sure that it had a good contact there. And then once he realized that, hey, the only thing that's missing on this thing was a socket cover, he fixed that. And then he looked a little bit more in his microscope and he found some lines that were, some trace lines that were cut. And he put some wire on it and he soldered it, put some insulation on it, and the board was good to go. The board was good to go, like I said, but I know that's not his first board he worked on, and it won't be his last. And so another thing that you're going to have to do, and the one thing I'm going to have to do as I looked at this, is make sure that when you're soldering or whatever you're doing, make sure that you have a good exhaust system to get some of those fumes out of there. You don't want to be breathing in that stuff and getting yourself sick. So, safety first, take care of yourself out there. Thanks again for coming by the reactionary video. We're going to be doing a lot of these. I'm going to be sharing a lot of things that I love, everything that I watch. So it's going to be various things. So make sure you like or subscribe and keep us encouraged in what we're doing. And we will see you on the next one. Thanks again.